Hello everyone, my name is Raina DeJute and welcome to my Module 11 LeetCode problem solving video. In this video, I will cover 4 LeetCode problems, which is merge intervals, insert interval, merge two sorted lists, and linked list cycle. So just to be upfront, I did use AI to help generate the initial solutions to all 4 of these problems. Not only did I not know how to do them, but my brain is also fried from trying to understand Spring Boot architecture this week. But my goal is not just to memorize the code, it's to understand the patterns and the reasoning behind what's actually happening. So I'm going to explain these from the perspective of someone translating them into a JavaScript mindset, because I still don't fully understand how Java works. So without further ado, let's get into the first problem, which is merge intervals. So from a JavaScript perspective, my initial instinct with this problem is normally to just loop through the array, compare items as I go, and maybe use a map or reduce. What I had to learn here is that the key step is sorting intervals first. Once everything is sorted by the start value, the problem becomes much simpler. So after sorting, I only need to compare the current interval with the last interval I've added to my result. If they overlap, I merge them by extending the end value. If they don't overlap, I just add a new interval. What made this make sense to me is that sorting removes complexity. So instead of thinking about all of the possible comparisons, I only ever compare adjacent intervals. So the main pattern here is sorting first, then merging as you iterate through it once. The second problem is insert interval. So this one builds on the last one. In JavaScript, I would normally think about this as inserting an element into an array and then reprocessing or sorting again, but that's not the most efficient option here. The approach instead breaks the problem into 3 phases. As you can see, there's 3 sections. First, we go through all of the intervals that end before the new interval starts and just add them directly to the result. Then we handle everything that overlaps with the new interval. So in this step, I expand the new interval to absorb all the overlapping intervals. And then finally, we add the remaining intervals that come after. What I realize here is that we don't need to reprocess the entire array. We just need to find the correct window where the insertion and merging happens. This feels more structured than typical JavaScript array manipulation, where I would normally just rely on higher order functions. And then we can move on to merge two sorted lists. This one is harder for me to understand because I'm used to working with arrays in JavaScript, not linked lists. In JavaScript, I would normally just merge 2 arrays and sort them, or maybe use pointers on array with indexes. But here, instead of indexes, we're working with nodes and pointers. The idea here is still similar though. So you compare the current node of both lists, pick the smaller one, and then move that pointer forward. You repeat this until one of the lists runs out. Once the one list is empty, you just attach the rest of the other list. The key idea here is that we never go backwards, so each pointer only moves forwards, which makes the algorithm more efficient. Conceptually, it's the same idea as merging 2 sorted arrays, which is a previous problem, just implemented with linked lists and nodes instead of array indexes. And then we have linked list cycle. So again, my first instinct coming from JavaScript would be to use a set to track nodes I've already seen. If I ever see a node again, I would just return true. That works, but it uses extra memory. The more optimal solution uses something called the fast and slow pointer technique. We create 2 pointers. One moves 1 step at a time, and the other moves 2 steps at a time. If there's a cycle, the fast pointer will eventually catch up to the slow pointer inside of the loop. If there is no cycle, the fast pointer will eventually reach the end of the list. What I found interesting here is that instead of tracking history like I would in JavaScript, we rely on movement and structure alone to detect repetition. It's a pretty different way of thinking, especially when it comes to LeetCode problems. So overall, with these problems, what stood out to me is how different this style of thinking is from JavaScript development, much like the entire project this week. In JavaScript, I'm used to flexible data, built-in array methods, and more dynamic structures. Here, everything is more rigid and structured, and the solutions rely heavily on patterns rather than convenience methods. So I didn't solve these from scratch. I used AI to help generate solutions, but I focused on understanding why each approach works and what pattern it represents. Now I'm starting to recognize the patterns more than the syntax itself, and that's the main thing that I want to get out of these problems anyway. Specifically, when I started Module 11 and we started getting into Java and SQL databases, all these LeetCode problems with hash maps started coming back to my mind because it's basically an SQL database. You've got foreign keys and you've got tables and you want to make them talk to each other, but they can't merge. It's just cool to see how the patterns from previous LeetCode problems all culminated to this Spring Boot MVC rocket delivery app. So that's all I have for this video. Thank you for watching, and I will see you next week.